Okay, good afternoon, everyone. In this occasion, we are from Group 2, consists of me, Vira, Isan, and Tutus would like to present our critical design review CDR. The title is An Ergonomic Chair for College Student in Indonesia. So the overall of this project or abstract, this is the final product is the proper ergonomic chair design that promote education quality and comfort, increasing confidence and concentration in the educational environment. So the purpose of this project is to redesign an ergonomic chair for college students in Indonesia that is accordance with the anthropometry of student bodies in order to prevent the health problems that are associated with poor sitting posture, which is one of the body investment. The scope is the project is only created in the backrest of the chair and in the table. So the references of this project is come from several journals and books that cover topics such as student chairs, design, and anthropometry data. So the background of this project come from a journal from Chang's state that state 16% of adults experience lower back pain due to the sitting problem in doing their work or activities are mostly done by sitting. So the concept of this project are uh, the student chair system will adjust the angle of the backrest, adjust table rotation, and also expand the table. So this is our system overview. Um, so this overview um, that that start from utilizing the chart in initial configuration, which is the folded condition. Then the student can open it, make any necessary adjustment, and expand on certain features that were supplied to enhance their learning in classroom. So the second stage is system requirement. So this is a functional requirement. The requirement is still same as a previous document, which is PDR, but we make adjustment and also revision in some parts. This is technology requirement, the startup performance requirement, and also utilization or constraint requirement. So this is system test requirement and also test verification. Same as previous slide. This table also the same as previous document, which is PDR, but we adjust and revise in some part. As you can see in the screen. Okay, the third stage is summary of PDR result that will be explained by Isan. To Isan, time is yours.
Okay, thank you for the change. So this is the summary of the PDR results. So in the previous PDR part, there was just one alternative design that is meet all the requirements of this project. So in this part, we will add one more design alternative so that it can be compared with that design. So basically here, this table shows the main difference between the both designs in mechanism table 1 and type 1 and table mechanism in type 2. Uh, Based on this consideration in the table, we end up with the mechanism table type 1. So for detail, we can see in the next screen. So here the table mechanism type 1. So for our design later on, we will use this type. In this type, basically the original form save the space by hiding the expand the table. When the students want to use it, they can get the part out from inside and move it to the left or the right based on their needs. For the armrest itself, it can be adjusted by enter the part to inside the table and place it to the right or left part. And if needed, the part can be saved inside the table as well. And go to the second type, which is table mechanism type 1. So in this option, the mechanism to expand the table is by opening the folded part of the under table. So the expanded table is placed under the table, but it is considered that it will span more spaces in the original form. And for the armrest, we can adjust it by sliding it to the left or to the right based on the student needs. And then go to the next slide. which is the third studies both methods. So this part will show the trade-off analysis for our design type alternative. So the team uses both concepts to compare all the design types and select the most suited to the project needs. And this criteria that is selected that considered by the team consists of cost, duration, complexity, and space consumptions. After choosing that criterion, the team assigned a weight for each. Next, the team rated the two design on a scale of 1 until 10, where the best will be scored 10. And then each rating was multiplied by the given math score and summed together to get the total score. And for the results, in the trade-off analysis, it is shown that uh, we end up with the design one, which has a total score of 5.7, while the score of the design two has the total score of 5.5. And then go to the next part, which is top level design of final concepts. Next slide, please. Yeah. Okay. In this part, the first one here, the screen displays in the figure how each separated parts be connected to build the ergonomic chair. The parts is divided into 5 parts, which are part A, it is the foreleg and backrest of the chair, part B, back leg of the chair, part C, the chair seat, part D is the table support, and the part E is table and armrest. And then go to the next slide, which is the full concept of the design. So this figure shows the dimensional detail of the chair that will be applied to the design later on. And then this is the part 5, which is the assemblies and interface design. So go to the next slide. So yeah, for the sub assembly one, which is the fork legs and backrest of ergonomic chair, the table shows the trade-off analysis to choose between two materials for the forex frame. So there are iron and aluminum. So based on the several consideration, we end up with by choosing the aluminum material for our backlight frame, and this is the interface of the backlight frame. And then go to the next slide, which is the sub-assembly 2, which is the back legs and of ergonomic chair. So this figure shows the interface of the design. So this part will be linked to the front legs, which is will be used to support the student's weight while sitting. Also, for consideration, the material used is the same as the previous part, which is the front leg frame. And then go to the next slide, which is the subassembly 3, which is the seat chair. In this, a figure shows the interface design. So in order to add the comfort, an important part, which is this part, is need to be considered as well. So this part will be put together after the part A and part B are assembled with a predetermined slope to increase student comfort. The material chosen in this part is foam padding. So this material will actually adjust to be flexible because it can adjust the shape when set on by the student. And then go to the next slide. Uh, this is the sub-assembly 4. This part that are support the table when the table wanted to be used. So either in the folded position or the used position, this part will blend with the rest of the frame. So the material used for this table support will be the same as the part A and part B previously, which is the aluminum one. And then go to the next one, which is the subassembly 5, which is the table and armrest of the ergonomic student chair. So this table shows the trade-off analysis for choosing the material, either teak or mahogany one. And then yeah, go to the sixth part, which is subsystem design and interface design. So for next slide, subsystem one, which is backrest adjustment system. The purpose is to provide flexibility for students to be able to adjust the angle of the chair back. This system can help comfort in carrying out activities in the classroom, such as supporting students to maintain the good posture while studying or providing an appropriate angle of student either in study or lean to take a rest. And this figure shows the interface of the adjustment system, and then the table shows the detail of the adjustment system. In a subsystem 2, which is the table expansion system, the purpose is to provide the flexibility for students to choose to have the additional space on the desk to store their belongings. So when they want to have the original position, they can have it, but they can they want to expand the space, they can adjust the table. So this table shows the dimension detail and the interface design. And then go to the subsystem 3, the armrest adjustment system. The purpose is to provide the flexibility for students as well, so that the armrest can be adjusted to the position of the right or the left based on the student needs. So this system can help for comfort in conducting the activities while studying, so the students' arms can be placed in comfort position and don't get tired easily. The table shows the detail and there is the figure of the interface design as well. So for the next part, analysis will be explained by Tutus.
For the next analysis part, we conduct the analysis using CMDQ or Cornell Musculoskeletal Discomfort Questionnaire from the student collected data ranging from 18 to 22 years old. We compare with the REBA, Rapid Entire Body Assessment Analysis, in order to define the new appropriate design dimension for the ergonomic chairs. Next. For the development plan, we have 3 stages, which is the software design. We use Blender for the three-dimensional to build our ergonomic chair design. Next, we use the analysis of the CMDQ that compare with the RIBA analysis. And the last one, we use the working prototype to develop the design that we call with the material using pin joint and welding process. Next. For the budget and suppliers, we have 3 main parts of the materials, and the total cost not exceed that our previous defined requirement, which is 600,000 rupiah. For the requirement review or acceptance test plan, here we describe our requirement also for the verification method, and the factor determine whether our verification method has passed or not our specific requirement. So for the chair and pin joint, we must use the demonstration test. Also for the backrest and expandable table. For the material characteristic, we use the test for the strength, durability, and the fineness. Next. For the risk analysis, here we have planned the risks in the 5 total. For the risk 1 is the additional material, risk 2 improper design application, and risk 3 improper raw material, risk 4 human and machine error in the manufacturing process, and the last is risk 5 improper angle used. Next, we plan the risks and the probability severity matrix to know the total probability risks. Next, we plot the risk and analysis mitigation in the risk severity matrix. For the project management update, CDR here marks the end of the fall semester of the human factor and ergonomic design. Our team has accomplished the required text, and for the next semester will be spent used for the developing and testing our design. All parts required to implement should be available in the middle of the December 2022. After that, our model will continue to the manufacturer. Until the end, the prototype will be improved during the January, and the finished product will be finished on the end of the January 2023. The last one is for the summary. So our project requirement that has preliminary determined should be tested, and we have several tests conducted to know how well the requirement satisfy the level of the requirement. Also, we have in the end of the process, we expected to continue during the raw materials, manufacturing, and the last one is the assembly part until the finished product at the end of the January 2023. I think that's all for our group. Thank you for the kind attention and see you.